y equals cosecant of x, guess what? The trick is going to look awfully similar as for graphing y equals cosecant of x as it did for secant of x. What's the helper going to be?
Y equals sine of x.
So your helper function is going to be y equals sine of x. What's the relationship between the two?
Reciprocal.
They are reciprocal functions. So the intercepts, the x-intercepts of y equals sine of x essentially give you the placement for the asymptotes of y equals cosecant. Does that make sense? That's why we use it. And it gives you a couple of points in the graph as well. So sine function, 1 period. There's one hill. There's one valley. Good enough. Okay, if it's just a basic sine function, what's the period? 2 pi. So label this scale mark 2 pi. Split it in half. Split that in half. Split the scale marks between pi and 2 pi in half. So same sort of scaling as before. And then so we're essentially plotting these points. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So 1, negative 1. It is that easy. I feel like I'm selling you a food processor. Is it really that easy? Yes, it's that easy to graph the sine function. 1 period of it anyway.
There's more.
But wait, there's more, exactly. So where are the asymptotes of its reciprocal? Or of the reciprocal, yeah, I said it right. Of the reciprocal, which would be 1 over sine of x, or cosecant. Wherever these intercepts are, right? So you can draw in the asymptotes. One of them is going to be right through the y-axis, isn't it? And then where else? Going to the right. Pi, pi. I just say that automatically now. Sorry if it's getting on your nerves. And then 2 pi. And then certainly if pi over 2, 1 is on the graph of sine of x, you take the reciprocal of 1, right? It's that same point will be on the graph of cosecant. Reciprocal of 1 is 1. But then you're going to get, if you plot a few points, convince yourself, you'll get this kind of U shape that approaches the respective asymptotes as it goes to the left and right. And then here, if 3 pi over 2, if the y-coordinate of negative 1 is a y-coordinate of, or is a value of sine of x, certainly it's a value of cosecant. And then it goes down from here. So it really is the same shapes that make up the graph of the cosecant. They're just placed in a different spot horizontally. Okay? The period we said was 2 pi. Domain would be the same as what? Since the denominator of the cosecant is sine of x, the domain would be the same as cotangent. So I'll let you look at that. The range is actually the same as what? Same as secant. So I'm kind of cheating, saving some time there.